In this tutorial, we will show you how to create a brand new bank project and how you can set up the clusters correctly from your file system. So first of all, assuming that this is your very first iPhone project for the course, let's go to launch your terminal and let's say just go to your home directory and then create a workspace for 3311. And now let's go into 3311. Now currently it is empty. So now let's launch EStudio. So currently it is summer 2015. So the current version to launch would be EStudio 15.01. If you are actually running the course in a later year or later semester, so just find the corresponding version number that correspond to your course. For the current term, it's 15.01. So EStudio 15.01 and ampersand to launch the EStudio on the background, so that after you have launched the EStudio, you can still type commands. Okay, let's do that. So you can see that the process is now run in the background. And if you go back to the same terminal, you can still type other normal commands, such as I can list the list of files in the system, in the directory. And currently it's still empty because we haven't created a project yet. Let's go back to EStudio. Because we are actually going to create a brand new basic application as opposed to adding some existing projects. So let's choose this option here, and then we'll say create. Over here, we have to choose a name for the system. For this case, let's just call it bank projects. As you can see, here, the location part is not quite correct. You actually have to browse into your workspace to make sure the project will be created for your in your 3311 workspace. Let's browse through our system, and this is my home directory and 3311 as I just created, and then I will say OK. You can see that now we are going to store the new projects under my home directory 3311, and then we should also, let's do it again to make sure it's the right path. We just store that under a directory called bank projects. So let's type this correctly. Okay, so this is where we are going to store our projects. So let's click on OK, and it's going to compile the project from scratch. Let's do that. As you can see, EStudio is not compiling for the very first time for your projects. Okay, so now we have got some very basic application projects that's compilable, which is generated by default by the EStudio for you. As you can see currently, we actually let's just have a very brief overview of how the EStudio work IDE, standing for Integrated Development environments. Let's see how the environments looks like. So you have the normal button here for file, for editing, for view, and favorite, so you can explore that further yourself. And here, this panel over here is editable, which means you can actually edit your program text as you develop your software. And this part here, depending on which tab you're clicking, it actually displays different views of your projects. And the one we were looking at is the output from the iPhone compiler. And this part, which is currently empty, is for displaying any type errors, because it is actually a very recommended practice for you to compile your program text maybe every 2 or 3 lines of code that you're going to write. You want to make sure you are making an incremental development that is correct, that is at least type correct. To actually make sure your software is correct, you have to write some test cases to run. Okay, so now let's draw your attention to these two panels here on the right. So this panel here is called groups. So this is basically like a package explorer in Eclipse. In iPhone, packages are called clusters. And clusters are basically symbolic names that refer to physical locations of your file system. That means more than 2 clusters might refer to the same location. On the other hand, when we are talking directories, every 2 directories should have distinct locations in your file system. So you really have to distinguish between directories, which are physical, and clusters, which are symbolic. By default, the EStudio is going to consider the project directory. Let me just go, let's have a look at the file system. So this is my home directory, and 3311 is the workspace I just created. And bank project is the directory that EStudio created for you, because remember, I actually specified the project path as bank projects. So currently, you already have some ifgen folder. So the ifgen folders is the generated C++ code that's generated by IFO compiler for you to actually finally to execute the system. For now, you don't actually have to worry about that. Right, you can see that the other 2 files that are generated by EStudio is first the application.e. So all the IFO class files are with the extension E, standing for IFO, of course. And also we have some file called ECF with the extension ECF. So ECF stands for IFO configuration. And presumably, the name of the ECF file corresponds to the name of your projects. If you click on that, you can see that it's actually basically an XML file with the tree structure, which contains all the setup information for your projects. For example, you can see that the name of your project is called bank projects, and with the target bank projects. And here, this line here specifies which class is the main class of your projects. And whenever you're going to execute your system, this will be the starting point for execution. And here we are saying the application class has a feature, and feature is the IFO term for methods in Java. So you better get used to this term, because I'm going to refer to features throughout the tutorial series. So for the application class, and in there's a make feature. And this feature specifically will be the entry point for execution. So this make feature here is similar to the main method in Java. However, in IFO, it is much more flexible, because this here the entry point does not have to be called make, and the entry point does not have to be application. You can choose whatever class you like and whatever feature you like. It doesn't have to be application.make. It can be, for example, another typical name for that would be called root. And here we can call root.make or root.make1, make2, etc. Let me just undo, because we don't need that for this tutorial. And here is the setup for checking the runtime assertions, because we know that IFO actually supports the idea of design by contracts. And the essence of design by contract is, except for the body implementation code for each of the features in your class, you actually have to specify contracts for your code. And contract usually come in one of the several forms. So we have precondition, which is checked before the feature is executed. We have postcondition, which is checked after the feature is executed. We also have some in-code in-code check assertions, which documents your own assumption about, at this point of time, at this point of the execution, I assume this to be the case, but is it really true? That's something IFO can check for you at the runtime. And also we have the class invariants, and also we have the loop invariants. We will not cover loop invariant in this tutorial series, but later on in the lecture we will do. And this supplier precondition means every time when you actually make a feature call in your body implementation, you will be wearing the client's hat, which means, for example, let's say I'm currently a bank application user, and in my application code, I'm actually trying to call the withdraw feature from the bank account class. So in this case, myself will be the client of the bank account, and the bank account class will be the supplier of the withdrawal feature. And when the supplier precondition is set to be true, that means at the runtime, IFO is going to check whenever I'm trying to call the withdraw feature from the bank account class, is its precondition satisfied before I call that? For example, the precondition could be that the current credits is actually enough for the proposed amounts to be withdrawn. If it is not, then the precondition for this supplier feature is violated, and it will be my obligation to actually satisfy that. We'll talk more about that and see more examples later in this later in the tutorial series. In this case, it says the console application is set to be true. So by default, EStudio assumes when you create a brand new project, it's going to be used as a console application, which means you're going to specify command line arguments. So there's a class called arguments, which they will. Let me just go back to EStudio to show you. So if you can see that by default, this is the application class, and by default, it is a child class or descending class of the arguments class, which provides the facilities for processing the command line arguments. But we are actually going to override this default later, because for the purpose of this bank projects, we are not going to create a console application. We're actually going to show you how to do test-driven developments. So test cases are the important point for this tutorial. We'll show you how to override this default option. Let's just go back to the ECF file to finish that off. And in this case, you can see that we have some library tag which sets the location for, by default, the base library of IFO. You can see that there is an environment variable, ISE library, which points to where you install the IFO library. And whenever you see the ECF file here and with a save suffix, that means that is the version of the library that imposes the void safety property, void safety constraint. We will actually talk more about the void safety maybe in later tutorial and also in the lecture. But very briefly speaking, IFO uniquely supports the guarantee of void safety. So when I talk about void safety, it's really about the guarantee about no null pointer exceptions at the runtime. And you don't actually have to explicitly to check for every object that you're trying to call a feature that it is actually not void or not null. So IFO has a way to enable its type system to check that your code at the runtime will never have such void objects violations. So this is something that IFO can do at a compile time, which means when you click on the compile button without running the code, IFO can already tell you whether your code has to be fixed. Otherwise, you might have void objects violations at the runtime. Okay, that's a very brief introduction, but we'll talk more later in the course. Okay, so this is the cluster tag, which has the bank projects, of course. And here you can see that the location of the bank project is dot. So you can see that the way they specify the path is relative as opposed to absolute. So you can see the current directory is always considered to be the bank projects, which is the directory over here. Remember, we actually have 3311 workspace, and this bank project is the current directory as far as the current project is concerned. So this bank project directory is the current one. So every cluster that we are going to later to add into this project has to be relative to that directory, bank projects. Okay, so currently we haven't set up any cluster yet, but I will show you how very soon. Okay, so here we actually have some rule to exclude. So basically this is to say for the ifgens, which are basically the generated code files by IFO, which is not so exciting to show in the EStudio environments. So we are trying to exclude it from there. And also if you got any subversion files, they by default they also don't show in the EStudio. But for this part, usually you don't actually have to modify them, so you can leave them like they are. Okay, that's a very brief overview of how the ECF file looks like by default. So it would be very rare that you have to touch this ECF file, but if you really have to, sometimes it might be easier for you to fix any configuration errors. But as you gain more experience on EStudio, it's not really too bad. You just gotta be careful with modifying the XML configuration file. Okay, let's exit from there. So we have this ECF file generated, and we have the application class generated. So let's go back to our EStudio, and let's now go to, so here we have the groups panel, which shows all the clusters currently. So as you can see, we only have the bank projects cluster. However, it's actually just by default, because by default, EStudio creates a cluster that corresponds to the name of your projects, which is called bank projects. And if you go to projects and project settings, and so this is where you can play with the settings instead of modifying the ECF file. So let's go to groups, and you can see this location here called clusters. So let's expand that. You can see this, the bank project cluster. If you look at that, you can see the location is dot, which means the current directory. Remember what I said? I said the bank projects, the top level of our project here is actually the current directory. So EStudio is considering this directory as the bank project cluster, which means it creates a symbolic name called bank projects to this bank projects directory. Okay. Now, what we want to do is to somehow modify this default structure a little bit to show you the flavor of playing with between clusters and directories. It's really straightforward, so don't panic too much. So what we want to do is to have a separation concerns. So somehow we don't really want to put the files just at a flat level. We want to have some hierarchical structure. So typically, we will have a directory called root. And just drag and drop there into the bank project. Let me just go into bank project so it will be easier. So now we're within the bank projects directory in the file system. We just created a root directory, and we are going to put the application class in there. But I will show you what if you don't. Okay, I'm going to show you. You really have to put it there. Okay. Now the second directory I want to create is the bank. So this is where the business logic will go, because this is a project about a bank. So we should have a bank directory. And then since we're going to illustrate the test-driven developments, and always you should have a dedicated directory for storing test cases for your software. So let's just call it tests. Okay, so now we have created 3 new directories, and now we're actually going to create symbolic names to each one of them as a cluster. Okay, let's see how we can do that. Let's go back to project setting, and let's click on clusters. Either you can click on this icon here, which says add cluster, or you can right click on that and say add cluster. Let's first do the root cluster. So we are creating a symbolic name called root, which will refer to from bank projects. So I'm actually trying to specify a relative path as opposed to absolute path to actually make sure your software is portable. Okay, so instead of saying users, Jackie, and then 3311 bank projects and then root, this is a no-no. So this is the absolute path that wouldn't make your project portable. What you have to say instead is to say whatever the directory of my current project is, which the system will be able to figure out, I want to get a root from there. Okay, let's do this. and say OK. So now we have a root directory, and you can see that now its location has been set properly. Okay, let's do the same for the other two directories. Now we're going to create a symbolic name called bank for the bank directory, and using the relative path. And we say OK, and you can see double check with the location here. And now let's do for the final directory, which is called the tests. So we have a symbolic name that corresponds to the name of the actual directory, just to make it easy for you to do. Let's say OK. And now let's say OK again. OK. So now we are going to compile the system and see if that will compile. Let's see what happens. If we compile, that is OK. So now that means actually we have no error for our, let's have a look at the, however, you can see that, there's one thing I forgot to do, because the only 3 clusters we want to maintain are the bank, root, and tests. And the bank project, which refers to the current directory, the top directory, is kind of redundant, so we want to remove that. And the way to remove that is simply, you can, there are 2 ways to remove that. Either you go to the groups view and then right click on that, and you can say remove the current item. Removing that will only remove the symbolic name rather than removing the actual directory in your file system. Okay, but let me show you from the project settings. It's always the best place to go if you want to play around with your directory structure. Let's now remove the bank project, which is a symbolic name for the current location, which is the current directory for bank projects. Let's remove that by right click and say remove. Yes, I want to remove that. And let's say OK. So now let's compile. So we should expect to see that bank, root, and tests will be the only 3 clusters for our projects. And this bank project cluster should be gone after I say recompile. So let's recompile. Aha! So this is the compile time error I want to show you. So let's see. So now whenever you see this any under this error list tag, if this part is actually non-empty, if it shows something, that means you actually failed to compile your code. And you should stop your current development and try to fix that before you can go on. Okay, so now usually there's a plus sign over here for you to expand the error message. But you can see there's an error code here, shows you what the error is about, and also you have some like a 1-sentence summary. So in this case, it shows unknown root class. So let's expand that. So this is basically the detailed error message. So somehow it is saying unknown root class. As I explained before, if you go back to the file system, the application class is actually the root class or the main entry point for execution for this project. But it is really there. So why does EStudio complain that it is not there? So this is something you really have to understand. Because EFO has the unique notions of clusters, which means anything that's outside of the clusters you have set up would be considered as non-existent. Because we have now so currently we actually have we should have 1, 2, and 3 clusters, and we have just deleted the bank projects cluster. So that means anything that's outside of the locations in the file system that are pointed by bank, root, and tests are considered as non-existent by the EStudio. If you go to the file system and look at that, application is actually not stored in here, here, or here, right? So although you can see that it does exist in the file system, but as far as the EStudio clusters notation is concerned, it is not considered as existent. So the fix to do is to drag and drop the application to one of the clusters. So of course, that's actually why we created a cluster called root. Let's drag and drop it there. So now let's recompile again. Yes, because you can see. So now if we recompile and you double check with the groups panel again, so now we do have only 3 clusters: bank, root, and tests. And the default bank project cluster has been removed. But to remove that, we gotta make sure all the important classes that are outside of these 3 locations are actually moved to the right clusters. Okay, basically this is now it comes to the end of this current tutorial. So we have created a brand new bank project and with the 3 clusters. And there's one more thing to do before I finish that. Because we're going to demonstrate test-driven development, and the testing library we are going to use, which is called the ESpec library. So ESpec stands for IFO specification. It is not included in the library by default. As you can see from the groups panel, the only libraries we have are the base library, which contains linked list, array, hash set, etc., and also some precompiled base library. And you can see there's no testing library over here. So the way to add the testing library into our projects is by, again, going to projects, project settings, and let's go under libraries. And here you can see there's only base over here. So the way to add it is similar to how you add a new cluster. Either you can right click on the libraries and say add library, or you can click on this plus sign here called add library. Let's use this option this time. If we do that, so you have a filter search bar over here, so you can either browse through to find ESpec, or you can simply just type ESpec. Okay, so this is the one to select, and I need to draw your attention to one subtle detail. So if you expand this window a little bit, you can see that when we select ESpec, it actually points to the location of the configuration file of the ESpec library, the testing library. Again, ESpec stands for IFO specification. You can see that we are referring to some ECF file that is called ESpec-save. As I said before, whenever you see the -save suffix in the IFO context, that means this library has the guarantee of voice safety at compile time. Okay, and again, this path here is also relative. Somehow it's parameterized by the environment's variable of your current installation. So it's very important that you put a $sign ISE library as opposed to some absolute path in your local machine. Okay, so the important thing to bear in mind is to make sure every time when you add the testing library, this has to be the version of the ECF file you choose, which is the safe version. Okay, let's say OK to add a library. Okay, so now let's say OK and recompile. Okay, so now you can see that under libraries in the groups panel, we do have the ESpec library. So now we have done what we are supposed to do for this tutorial. We have created a brand new project for the bank, and then we have created 3 physical directories in our bank projects: bank, root, and tests. And we also show you some overview of the configuration file that's generated by the EStudio. And we also show you how you can play with the basic features of project settings over here to add a cluster or to add a library. And also you can set a cluster with the relative path, the path that's relative to the current project directory location. Okay, that's the end of this tutorial, and we'll start adding stuff in the later tutorial to this bank project. So stay watching.